Now in our curriculum, we're not doing section 3, which is on complex rational expressions. There are techniques to get it done, but as I say, we don't do that. So we will continue on to section 4, which are rational equations. So let's take a moment and fill these in. So by definition, a rational equations contain one or more rational expressions. And remember, these would be equations that contain fractions. To solve a rational equation is to find all of its solutions. Now, when we say all here, if we have an equation that's to the first degree, we're going to get one answer. If we have it to the second degree, we'll get two answers. Equations to the third degree, you're going to have three answers. And we solve rational equations by multiplying each term by the least common multiple of the denominators, which we worked on a little bit in section 1, or 2, I should say. When we multiply an equation by the least common multiple, we are clearing fractions. Now, it's not the same equation anymore, but it's an equivalent equation where x still has the same value, but there's no fractions, and it's easier to work with. So as we start on these, let's do it in phases. For instance, to get rid of the fractions here, what is my least common multiple? And the answer is 20. So we're going to multiply each term by 20. How about in number 6? What's my least common multiple? So here it would be 10t. Now here it gets a little more challenging because we have an 8 there, but if I factor this, I get 2x plus 2. So my least common multiple will be 8 times this. Now, instead of writing it by each term, another technique would be 8 times x plus 2. Okay? All right, now let's go to solve these. So we're going to illustrate a couple of techniques here. We said our common denominator here was 20. So we're going to multiply each by 20. 5 goes into 20 4 times. 4 goes into 20 5 times, and here we don't have any canceling. So we then go 4 times x is 4x. 5 times x is 5x. 9 times 20 is 180. Group like terms. Divide both sides by 9. X equals 20. And that checks. Now I undid what I had there before. I'm going to use this method over here and show it to you. So 5 goes into 10 twice. So here we're left with a 2t, and the 5 cancels out. T will go into there t times, and we're just left with the 10. And 2 will go into there 5t times. And again, we're getting rid of the fractions. So this is just another method. So 2t times 2 is 4t. Now a negative 10 times 1 is negative 10. And 5t times 1 is 5t. We're going to transpose the 4t to keep our t's positive. We end up with a t equals negative 10, and this checks. Now here we're going to cancel this with this, and we're left with an 8. Here the 8 cancels with that, and we're left with a x plus 2. Now this is tricky. This will cancel with that. The 2 will cancel with the 8 and leave me a 4. So continuing, we're going to go 8 times 4 is 32. Then 5 times x is 5x. 5 times 2 is 10. 4 times 3 is 12. Group like terms. Transpose my 42 to the other side. That gives me a negative 30 over there. Divide both sides by 5. I get x equals a negative 6. And that checks. Again, in our next few, we'll look for strategy and our least common multiple. What would we multiply every term by to get rid of all the fractions? Well, I have 9 times something, 4 times something, 12 times something, and can you see 36? And we need the t. So we're going to multiply each term by 36t. That would get rid of all of our fractions. Here we're going to multiply each term by x. And if you guessed that, that was good. Now here we're going to multiply each term, because it's a common denominator in a sense, n plus 1. Alright, let's change colors and see where we go. So 9 will go into there 4 times, so it's 4t times 3. That cancels out the 9. 4t will go into there 9 times. And 12 goes into there 3t times. And then here we don't have anything, so that's x times x. Here the x's cancel out, and here we get 7x. Now here both of these cancel out, and we are just left with n plus 3 equals 2. And let's just finish these up here. This is going to be x squared plus 10 equals 7x. That looks like a quadratic. We have to put it in standard form to factor it. This becomes a negative x, putting it in order. And this one up here is going to become 12t minus 9 equals 12t. Ooh, this one's interesting. Here we subtract 12t from both sides. We get negative 9 equals 0. Is that a true statement? No. So for this one, there's no solution. For this one, we have to factor. and it's an X and a 5 and a 2 and a minus, so we have X equals 2, X equals 5. Okay, so those are our solutions. Now here, when we do this, we're going to get X, and I should say, equals a -1. Now notice, if we put a -1 in our denominator here, it's going to make it a 0. So even though we ended up with an answer, there is no solution for this, because our -1 makes our denominator a 0. Now, a technique that you may or may not have been introduced to yet is that we can actually cross multiply when you have a fraction equals a fraction. Okay, so this will then become t. Let me do it. So this is a little higher one. So again, we're just going to cross multiply here. So t times this, and then 9 times this, which is what I've done. I did this, transposed it, so it equals 0. Now I have a equation to the 3rd degree, but it's 4 terms, so I'm going to factor it by grouping. Take these 2 terms, and I can take a t squared out of these, and here I'm going to take a -9 out of these, and I have this common factor that I put here. Then I bring in my t squared minus 9, that I see is the difference of perfect squares, that I'll factor into its conjugates. Equal each of the conjugates to 0. Here this is t is a -3. Here t is a +3. And here t is a -3. Again, it's to the 3rd degree, so I get 3 answers. Notice 2 are the same. And when I put this answer over here, I see it makes my denominator a 0. So my -3's don't work. The only answer that does is t equals 3. And we spent a little bit of time and used lots of our skills to get there. We use the same technique for 12. So we're going to cross multiply, which I've set up there. We distribute and collected like terms. There wasn't any. I'm going to bring this 4x over, subtract 4x, it becomes 11x, subtract 20 or transpose, and we divide by an 11, and there's my answer. And that checks. Now, once again, what I want to do is show you the technique of getting rid of these fractions. And I'm not going to do every one. I skipped one already. So here my least common multiple will be t times t minus 3. And they are kind to us in that here it's going to be this multiplies to this. So our least common multiple is x minus 1 times x plus 2. And the same thing here. This will be n times n plus 1. So let's get the equation here. So we're going to cancel this with this, and this becomes then 20t. Then there's a negative. We have to be sure we have our negative there. So t will cancel out there, and we're left then with -15 times t minus 3. And now the t cancels out again, and we're left with 30 times t minus 3. So we're like with equations back in chapter 2. We just have to distribute and solve for t. Now for number 15, this will cancel with that, and we're then left with 5 times x plus 2. So this cancels. We multiply this times 5. Then there's a negative 6. This cancels with this one, and we're left with x minus 1. And that will equal, now since this is both of these, we're just left with a 3x. So again, much easier to do using this technique of getting rid of fractions. And the same applies here. This will cancel with this, so we're going to get n times n, which is going to be n squared, minus, now the n cancels with that, and we're left with a negative 2 times n plus 1. And then this is this, so we're just left with a 1. Now remember, if we get n is a negative 1 somewhere in there, that one would be excluded. If we get n is a 0, that would be excluded. So that's what you need to watch. So to give you the answers, and they are in the answer key, t is this for 14, x is this for 15, and for 16 you might put n is 3 and a negative 1. But remember, if I said if n were a negative 1, it would make our denominator over here a 0, so n as a negative 1 is excluded. Okay, there are more examples, but again, what we're interested here in doing is understanding what's going on. So they're giving us a function notation. F of x is this when that is that. So we're just doing this equals that. And our common denominator here would be x. And the same thing applies here. And we equal them, and here we can just cross multiply. These last two are quite tedious, but the pattern is basically that this equals this, and this equals this. So it'd be quite a tedious job, and I'm not sure they're going to ask you to do those, but that would be a challenge. Okay, another section.